Hi, welcome back. And last where we left off was chapter 1.2, and now we're on chapter 1.2 review questions, which are a little bit more difficult. So that you guys can give these a try. So you can just pause the video and give it a try. And yeah, I'll get started off by doing the questions. So I'll start by doing question 1. So you would assume for this question that the initial velocity is actually 0 because it's leaving the starting gate. So initially it'll be standing still and then it'll be starting to accelerate. So you assume that the initial velocity is 0. You're told to find displacement, so displacement equals vi times time plus half acceleration times time squared. We have initial velocity, we have time, and we have acceleration. All you have to do is find displacement, so initial velocity 0 times 5.2 plus half 4.1 times 5.2 squared, and that gives you times 4.1 2 squared. That gives you roughly 55 meters. 55.432, which is roughly 55 meters forwards. So if you want to find the final velocity, you have the initial velocity equals 0 meters per second. You have the acceleration, which is 4.1 meters per second squared forwards. And you have the time, which is 5.2 seconds. I know I wrote it up there, but I'm going to write it down here anyways. So you have all those variables. So now you could use Vf equals Vi plus acceleration times time, which is one of the formulas. I think it's equation 2. So Vf equals 0 plus 4.1 meters per second squared times 5.2 seconds. So you're left with meters per second, and that gives you 21.32 meters per second forwards. That's final velocity, which you can round to like 21 meters per second squared, meters per second forwards. So that's how you do question 1. You guys can try question 3 on your own. I'm going to do question 3, which seems a little bit more difficult. So a police officer at rest at the side of a highway notices a speeder moving at 62 kilometers per hour along a straight level road near an elementary school. When the speeder passes, the officer accelerates at 3 meters per second in pursuit. The speeder does not notice until the police officer catches up. So basically, there's a police officer standing still or just at rest, and a car passes by, and then once it passes by, the police officer starts driving forwards, starts chasing the car. So for this question, you're going to have to convert the kilometers per hour to meters per second, because this is acceleration is meter per second squared, and it's better to have all of them in the same unit, so that it's easier to do the calculations. Because if one's in kilometers per hour and one's in meters per second, it'll be hard to do the calculations. So put them in the same units. So I've already gone ahead and done this question. So the speeder is 62 kilometers per hour. I converted that to meters per second, so I got 17.22 meters per second. To do that, just do 62 times 1,000, which gives you 62,000 meters, and divided by 3,600, which gives you 17.22 meters per second. The initial velocity of the officer is 0 meters per second, because remember he's at rest, but the acceleration of the officer is 3.0 meters per second squared. So part A asks you, how long will it take for the officer to catch the speeder? So part A. So if you do an equation for the speeder, the displacement of the speeder equals 17.22, which is the velocity, times time. Because remember, velocity equals displacement over time, and if you rearrange that for displacement, you get displacement equals velocity times time. So 17.22 times time, you don't know what time is, and then you find the displacement equation for the officer. So 0 times time plus half acceleration times time squared. I'm pretty sure this is equation number 3 from the equation sheet, and you end up getting 1.5 times squared. Now the question is asking how long will it take for the officer to catch up. So for the officer to catch up, the displacement of the officer has to equal the displacement of the speeder. Because like remember, this is the officer, and then the speeder is like passes by. So once the officer catches up, the displacement is going to be the same. So at what time are both these displacements going to be the same? So to do that, you just equate both equations, which is what I did here. So displacement of the speeder equals displacement of the officer, and you plug in these equations, and you end up getting a quadratic equation. Because you move this over to the other side, you get a quadratic equation, and you can factor out the time and the 1.5, and you're left with 1.5 times time times time minus 11.4814. So if we set this part equal to 0, you know that the time will equal 11.48 seconds. So it'll take 11.48 seconds for the officer to reach the speeder. So that's how long it'll take for the officer's displacement to catch up to the speeder. So that's how you do part A. Now part B is how far will they move from the position where the officer was at rest. So to do this, you could do either equation. So you could either use this equation or this equation. You have the time, so it's telling you how far from rest will they move. So since you have the time, you can just take this time and plug it into one of the equations to find out how far it'll move. So I used the equation for the speeder to find out how far they'll move, so 11.48 seconds. So I took that, plugged into that equation, and that gave me 198 meters from rest. That's how far they moved from rest. Now part C is asking calculate the speed of the police car when the officer catches a speeder. So to do this part, you know that the acceleration is 3 meters per second for the police car, 3 meters per second squared. You know that the initial velocity is 0 meters per second because it's at rest. And you know that that's the two things you basically know. And you know that the time, that you already calculated the time, which is 11.48 seconds, so you know how much time it takes to catch up to the speeder. So now the question is asking you calculate the speed of the police car when the officer catches the speeder. So since this is the time it takes to catch the speeder, you have the time, you have the acceleration, and you have the initial velocity. So you can calculate the final velocity using this equation. So the initial velocity is 0 plus 3, which is the acceleration, times the time, and you end up getting 34.44 meters per second. Or if you convert this to kilometers per hour, it's 124 kilometers per hour. So to do part D, I'll show you how to do it right now. It's a little bit more difficult, but it makes sense after you've done it. So the police car is moving 10 kilometers per hour faster than the speeder. The speeder originally was moving 62 kilometers per hour. So that means the police car is now moving at 72 kilometers per hour. It was initially at rest, but then accelerates to 72 kilometers per hour, and the acceleration is still the same. So you know that the final velocity is 72 kilometers per hour, which is 20 meters per second when converted to meters per second. You know the acceleration, and you know the initial velocity of the officer. So now you want to calculate the time for the officer to reach this speed. So I've gone ahead, I've rearranged the acceleration formula. Remember, acceleration is Vf minus Vi over time. I've rearranged that formula in terms of time, and I got this. So the time it takes to reach that speed for the officer is 6.667 seconds. So now I want to find out how much the officer has traveled in that 6.667 seconds, or in that time that it was traveling at 20 meters per second, or 72 kilometers per hour. So at this speed, it has, I've used the displacement equation. I've used vf squared equals vi squared plus 2ad. I've rearranged that in terms of displacement, and I've got this. So it travels 66.67 meters in that time when it was at 20 meters per second. But remember, the speeder is also moving in that same time. The police car is not only moving, both the police car and the speeder are moving. So I calculate the distance traveled by the speeder as well. So displacement, the speeder was 17.22 meters per second as the velocity, and the time is the same as the police car. So the distance of travel was 114.82 meters. Now the distance for the police car to catch up, you have to calculate, because the police car still hasn't caught up to the speeder at this point. It's still far behind. So I've gone ahead and calculated the distance for left officer to catch up to the speeder. So I've taken this and subtracted it with that to get the remaining distance that the officer has to travel, which is 48.15 meters. So the speeder is basically 48.15 meters ahead of the officer. So you could say that the displacement of the officer equals the displacement of the speeder plus 48.149 meters. Because remember, the displacement of the speeder is a certain amount plus 48.145, because this is how much many meters it is in front of the officer. So the officer's displacement so once the officer catches up to the speeder, it's going to equal to the displacement of the speeder plus 149. So that's why I equated them, because I want to find out when the officer catches up to the speeder. So I've gone ahead, I've subbed in the values. So 20 times time, 20 meters per second times time equals 17.22 times time, which is the 17.22 is the velocity of the speeder, and you don't know the time it takes to catch up for the remaining 48 meters. So then after I've done all of this, I've moved everything to the other side, and I've been left with time equals 17.319. So that's how much time it takes to catch up to the speeder. So the remaining 48.15 meters that the speeder is in front of the police officer, it takes 17.319 seconds to catch up to that distance. So that means the total time needed is 17.39 plus the 6.667 seconds. So total time is going to be 24 seconds.